On this F150 with the 5.0L P0174 is a System 2 lean code for Bank 2. In plain shop terms, the PCM may be adding fuel because that side of the engine looks lean, and the adaptive fuel strategy has reached its rich calibrated limit. The truck may have a lean complaint, roughness, or just a check engine light. The broad areas that can be involved are intake or vacuum leaks, PCV and EVAP purge concerns, fuel delivery, fuel quality, MAF input, exhaust or oxygen sensor circuit issues, and basic connector or wiring problems. Start with the basic system checks, then follow a structured diagnostic approach instead of clearing memory and losing the conditions that set the code. First, check the codes. If other codes are present, check what they mean first. For a rich or lean system code like this, do not clear the codes and do not reset KAM yet. Record the ECT or ECT1 value from the captured operating data so you can recreate the concern. With the ignition off, do a careful visual inspection before touching deeper tests. Air filter and housing, intake tract from the MAF to the intake manifold, throttle plate, vacuum hoses and T's, EVAP lines, intake manifold sealing, EGR and PCV hardware, exhaust flanges and gaskets, oxygen sensor wiring and pins, contamination, cross-sensor wiring, and make sure the dipstick tube and oil fill cap are seated. If you find a vacuum leak concern, go straight to vacuum leak verification. If you find another obvious concern, repair it, clear PCM codes, and repeat the self-test. Watch yourself around a hot engine. Use the normal precautions to avoid contact with hot components. If the visual inspection does not show the fault, run the relative injector flow test using the scan tool process. If that test fails, install the fuel injector in question, reset KAM, clear PCM codes, and repeat the self-test. If it passes, run the power balance test. If power balance fails, install the applicable fuel injector, reset KAM, clear PCM codes, and repeat the self-test. If power balance passes, check the EVAP system for a purge valve stuck open. Use the scan tool EVAP CPV check when available. If that test is not available, record FTP with the key on, start the engine, command EVAP purge to 0%, command the vent valve on, and watch FTP. The purge check passes if FTP stays within 0.5 V of the recorded PID voltage within 30 seconds after closing the purge valve. If it does not, install a new EVAP canister purge valve, clear PCM codes, and repeat the self-test. Next, check for a vacuum leak using fuel trims. Start the engine and monitor CHT, ECT, ECT1, IAT, long-term and short-term trims on both banks. Recreate the captured conditions. The vacuum leak comparison uses engine temperature between 82 degrees C, 101 degrees C, 180 degrees F, 215 degrees F, and intake air temperature less than 46 degrees C, 115 degrees F. Add long-term and short-term trim for each bank at idle, then raise engine speed to 3,500 RPM for 10 seconds and add the trims again. Fuel trim at idle is more sensitive to a vacuum leak because unmetered air is a bigger share of airflow at idle than it is off idle. For P0174, if the total fuel correction difference between idle and 3,500 RPM is less than 15% of the total value at idle, continue into fuel pressure testing. If the difference is not less than that, go find the vacuum leak. There is also a MAP voltage check in this routine. With the key on, record MAPV, then start the engine and record MAPV again. If the PID changes, the lean code path continues into fuel pressure testing. If it does not change, move into MAP diagnosis rather than guessing. To locate the vacuum leak, identify the intake air and PCV vacuum T's, start the engine and monitor short-term fuel trim on both banks. Restrict vacuum lines one at a time for 30 seconds. Do not clamp or pinch a hard plastic hose. Use a vacuum cap or equivalent. If the short-term trim drops greater than 15% when a hose is restricted, repair that leak and verify it. For verification, record short-term trim before the repair with the engine stabilized at the concerned conditions. Repair the leak, restart and stabilize the engine again, then compare the new trim to the old value. If the drop is greater than 15%, reset KAM and repeat the self-test. If it is not, a vacuum leak is still present, so go back through the leak locating routine instead of guessing. If the diagnostic path takes you through the universal oxygen sensor pump cell circuit before fuel pressure, disconnect the sensor and PCM connectors and check the applicable 5.0L circuits. A good circuit is less than 5 ohms. If it is not, repair the open, reset KAM and repeat the self-test. If the trim pattern points away from a vacuum leak, move into fuel pressure testing. Relieve fuel pressure correctly, connect a mechanical fuel pressure gauge, pressurize the system, start the engine, let pressure stabilize, then run the pump to maximum pressure. Fuel may still be pressurized after the engine is shut off, so follow fuel handling and pressure relief precautions. The pass-fail range here is vehicle-specific. If you do not have the correct range for the vehicle in front of you, stop and get that range before calling the test good or bad. If pressure is not within range, move into fuel system diagnosis. If pressure is within range on this 5.0L path, check for a biased fuel rail pressure sensor. With the fuel injection pump connector disconnected, start the engine, monitor FRP, and command fuel mass die to maximum. If FRP is between 345-827 kPa 50-120 psi, continue. If it is not, install a new fuel rail pressure sensor, clear PCM codes, and repeat the self-test. On the branch that compares rail pressure to low side pressure, FRP must be within 138 kPa 20 psi of the FLP value. If it is not, install a new fuel rail pressure sensor, clear PCM codes, and repeat the self-test. Then check fast leak down. Run the pump to maximum pressure for approximately 5 seconds, command the pump off, let pressure stabilize, record it, and monitor for 10 seconds. It should remain within 34 kPa 5 psi of the recorded reading after 10 seconds. If it does not, inspect the tank lines and filler pipe for an external fuel leak. Repair any leak found, then continue with fuel system diagnosis and repeat the self-test after reset. If no external leak is found, move into the next fuel system leak down branch. For slow leak down, continue monitoring for 1 minute. The pressure should remain within 34 kPa 5 psi of the recorded reading on MRFS, or greater than 275 kPa 40 psi on ERFs after 1 minute. If it does not, continue with fuel system leak down diagnosis. If the branch points at electrical noise, inspect CKP harness routing, shielding, alterations, radio frequency interference, and excessive generator noise. Repair any concern found, clear PCM codes, and repeat the self-test. If pressure stability passes and the path stays with P0174, check the fuel mixture. Use a locally obtained 200 ml beaker and a 25 ml graduated cylinder. Put 5 ml of clean water in the beaker. Drain 22 ml of fuel into an approved clean container. Pour 20 ml of that fuel into the 25 ml graduated cylinder. Then add water until the total liquid volume is 24 ml. Stopper and shake the cylinder, then let it separate approximately 3 minutes. The ethanol and water settle to the bottom and the gasoline rises to the top. Record the separation level where the ethanol and water mixture meets the gasoline. To calculate ethanol percentage, take the recorded separation level, subtract the amount of water added, and multiply the new value by 5. If the fuel does not separate, replace the contaminated fuel. Clear PCM codes and repeat the self-test. If no ethanol is present on this lean code path, move into fuel system diagnosis. If ethanol is present on a flex fuel vehicle, compare FFINF to the calculated ethanol percentage. If FFINF is within 20% of the calculated value, move into fuel system diagnosis. If it is not, reset KAM, start the engine, monitor FFLRND, and drive approximately 3 km, 7 miles, or until the PID indicates yes. Then cycle the ignition and compare FFINF again. If it is now within 20%, Return the vehicle and advise correct flex fuel fueling practices, including staying with the same fuel for the next 2-3 refuels. If it still is not within 20%, continue with fuel system diagnosis. On a non-flex fuel vehicle, if ethanol content is less than 25%, move into fuel system diagnosis. If it is not less than 25%, repair as necessary. Advise the correct fuel type, reset KAM, and repeat the self-test. Small fuel additions or repeatedly switching between gasoline and an ethanol blend greater than E15 can prevent the PCM from learning the correct ethanol content. If the path continues past fuel quality into air metering and sensor checks, go back to the connector and sensor basics first. With the ignition off, disconnect the universal oxygen sensor connector and inspect for pinched, shorted, or corroded wiring and pins, oil or water contamination, crossed sensor wires, and a contaminated or damaged sensor. Repair any concern found, clear PCM codes, and repeat the self-test. If no connector or sensor concern is found, check MAF operation. Start the engine, monitor RPM, MAF-V, MAF-HZ, and MAF. Then run the engine at 500 RPM for 5 seconds, return to idle, and repeat. At idle, the MAF PID should be within 30% of the normal PID value. If it is not, continue MAF and IAT diagnosis. If it is, reconnect the universal oxygen sensor. Get the engine into closed-loop fuel control. Monitor RPM and the commanded equivalence ratio PIDs. Then raise engine speed to 2,000 RPM for 1 second and return to idle. If the equivalence ratio changes across one in either direction, the concern cannot be duplicated at that point. If it does not, the lean code path moves to the universal oxygen sensor operation check. There are a couple of shared branches in this routine that matter as context, even though they are not the main P0174 path. On the rich side branch, the check is for fuel leakage into the crankcase. Run the engine at normal operating temperature. Record long-term and short-term trims on both banks. Shut the engine off. Disconnect the PCV line at the intake manifold. Temporarily plug the intake port. Restart at normal operating temperature. And compare trims. If the trims shift and the rich condition is gone, install a new fuel injection pump. Clear PCM codes and repeat the self-test. On the oxygen sensor switching branch, run the engine at approximately 2,000 RPM and hold it for 3 minutes, then see whether the switching concern is present. If it is not present, the concern cannot be duplicated at that time. If the oxygen sensor switching branch is present, diagnose the sensor indicated by the code and check the harness. With the ignition off, disconnect the PCM connector and the applicable downstream oxygen sensor connector, then measure between the listed circuits for that sensor. The short between circuits check should be greater than 10K ohms. If it is not, repair the short, clear PCM codes and repeat the self-test. Next, check the oxygen sensor circuit for an open. On the 5.0L, use the listed connector pins for the applicable downstream sensor. A good circuit is less than 5 ohms. If it is not, repair the open, clear PCM codes and repeat the self-test. Then check for short to voltage. With the key on, measure the applicable sensor circuits. If any voltage is present, repair the short, clear PCM codes and repeat the self-test. If no voltage is present, reconnect the PCM and oxygen sensor connectors. Start the engine, let it idle for 2 minutes and record the applicable downstream oxygen sensor PID. If that PID is less than 1.5V, the concern cannot be duplicated at that time. If it is not less than 1.5V, move into the final oxygen sensor operation check. For a PCM operation branch, disconnect the PCM connectors, inspect for pushed-out pins and corrosion, reconnect everything fully and verify whether the concern is still present. If it is still present, install a new powertrain control module and complete the required programming. If it is gone, the system is operating correctly at that time, and the concern may have been a loose or corroded connector. For the universal oxygen sensor operation branch, disconnect the PCM connectors and the upstream universal oxygen sensor connectors. Inspect for pushed-out pins and corrosion. Reconnect and seat everything. Reset KAM and verify the concern. If it is still present, install a new universal HO2, reset KAM, and repeat the self-test. For the downstream oxygen sensor operation branch, do the same connector inspection and reseating at the PCM and downstream oxygen sensor connectors. If the concern remains, install a new HO2, reset KAM, and repeat the self-test. The big takeaway on P0174 is to prove the lean condition path in order. Preserve the captured data, inspect for obvious air and exhaust issues, use trims to separate vacuum leak from fuel delivery, then prove pressure, leak down, and fuel quality before condemning sensors or fuel parts. For more diagnostic training, visit Diagnostics.com.